All right, guys. My name is Kyle Nolan, and I'm the president of the Computer Science Club here at UIS. Today, we are happy to have Mike Eck from Global Velocity on with us, and there's Mike. And we've also got a few of our students here. We've got quite a few, and hopefully a few listening in. And this is actually going to be what we go through in our meeting on Friday. So, and also during this conversation, if you have any questions for us, please send me an email. If you've got access to Google Plus, there should be a little questions tab. You can throw something in there, or kind of reply to us on Facebook or Twitter, and I'll be monitoring that throughout the conversation. So, without further ado, let's go ahead and turn it over to Mike. You've got a nice PowerPoint for us, and let me pull that up for you. And there we go.
Great, thanks, Kyle. I hope just a sound check. Can you hear me okay?
Yeah, I can hear you just fine.
Excellent. Well, again, my name is Mike Eck, E-C-K. I am Director of Business Development for Global Velocity. Been with the company 6 years, and I'm very pleased to have been part of the process of arranging this research and development agreement between our company and your institution, the University of Illinois Springfield. I want to take a minute to thank one of your professors, Ron Louie, for being our champion and helping to make this happen and building the collaboration inside the university that's now resulting in, I believe there will be 2 members of the faculty, Josh Smith and Lucinda, is it Cagney? Caffey, who will be working with us and you all in moving forward. So, so the purpose of this is to introduce Global Velocity, what we do, and to begin this relationship, and we're very excited to do that. Next slide, please. I want to give you a little background about Global Velocity and then fast forward to now. We emerged from Washington University in St. Louis, the Applied Research Lab, early this century, and there was some very interesting work initially performed around the question of pattern matching on high-speed networks and how would that go using field programmable gate array FPGA technology. The results of that research led to the creation of a company. And in 2006, Greg Sullivan, a graduate of WashU who had commercialized and sold 2 other companies, took the reins. And Ron Louie, if ever you want to know more about that history, and it's quite interesting, Ron Louie was there in the beginning and can give you more details. So fast forwarding through time, we now claim a deep technical experience, a deep technical expertise in high-performance network sensing technology that includes deep packet inspection, and we've moved our business problem solving towards content protection. In other words, to protect data from a data breach. So we've developed a series of data loss prevention products, with the first one being the GB2010 that we have donated to you guys. I think the hallmark of what we do is that we are very flexible and scalable. Some recent work we're doing involves virtualization of our technology and making it play in the cloud as data moves to the cloud. So there's some very interesting new work going on in that area. Also, we perform and do content scanning and inspection of data, protecting data privacy at very high speeds. And we also have claims to high-performance computing techniques, the FPGA applications on outbound network flow. So that, in a nutshell, is Global Velocity. Next slide. So let me talk first about the business problem we solve. As we talk to literally hundreds of companies over the past several years, they describe a desire to protect data from data breaches. And the type of information they worry about falls in these three buckets. Intellectual property, this is generically speaking. So trade secrets, marketing plans. At Procter & Gamble in my backyard in Cincinnati where I live, it's the recipes and formulas and how to make products. Business contracts, and when we had a meeting with GM back in 2007, they worried about protecting the source code for OnStar. Other firms worry about being legally and regulatory compliance around credit card, having personal information about people, medical information, and so on. And then the more fuzzy area that companies struggle to define what's confidential and what's not includes business operational data. Another example from Procter & Gamble was a merger and acquisition discussion is confidential and private until it is revealed as having occurred and being public, or it will always be a secret, almost like it never happened. So the span of data is enormous. And these are real life examples of what the business world worries about today. Next slide. We'll put a little bit of a different spin on this same data, and a university, your university, worries about a subtly different list. Now, some of this came about as a result of our conversations with WashU over the years, and I do want to mention to you all that St. Louis University here is one of our beta customers, an early adopter of our technology, and we've learned a lot from them about the data they worry about. And so in their case, we're moving into some discussions with the VP of Research around protecting the research data that is going on within the university that must be kept confidential. Similar compliance issues and other university operations are subtly different. So this is the business problem. How do I make sure this data doesn't leak into places it should not go? Next slide. So it's no secret, I think I'm preaching to the choir here. We know foreign governments are coming after our country's intellectual property. Cyber criminals are after credit cards. There is industrial espionage. But there's also a very innocent group of use cases, or use cases involving innocent people, where an employee, a trusted employee or contractor does an, oh my gosh, I didn't mean to do that. And so it could result in a data breach. Those are not uncommon. So this just puts the business problem out there. This is the problem Global Velocity is trying to help solve. Next slide. So bottom line, last business slide, but I think it's important to have this background because we wanted to make sure you all knew what our products are designed to do. Your team, your group, your club may choose to solve a different problem with this technology, and I think that's the fun part. With the advice of your faculty, advisors, and with Ron and others at the university, you've got a platform now you can play with and get serious with around other problems that require this horsepower. Bottom line, we, Global Velocity, enter the market helping companies reduce risk, to protect brand image. We had the CEO of a payroll services company called Ceridian in Minnesota say that if they had a data breach, their brand would be destroyed. That's a company that competes with ADP, if you've heard of them, and Paychex and firms like that. And then we help protect your company's secrets to help companies retain competitive edge. So those are the conversations we have with the leadership of companies, and then the technologists within the company is who we talk to about how we go about implementing our solutions. And let's go on to the next slide. So I wanted to touch on now the use cases that we have engineered our product to address. I've hinted on or suggested a few of these. The negligent, innocent insider oftentimes makes mistakes using corporate mail, SMTP mail, webmail, and potentially social media, where they attach the wrong attachment to a Facebook post. And oh my gosh, I didn't mean to do that. The malicious insider would be the use case where it's a renegade. It is somebody who intends to do harm. It could be somebody who is leaving a company and that they also can use similar techniques to get confidential information out of an enterprise. One company allows me to tell you this. We did reveal, our technology reveals, in performing the function that we do, we identified a broken business process, whereby the institution is a healthcare firm, and they submitted a batch job, and we revealed a process that was sending confidential information somewhere that surprised them. And once they did a deeper interrogation into the event, they learned that they were sending confidential patient information to a transcription service that they had canceled the contract on 3 years ago. Which, that's an oh my gosh, I forgot to turn off that batch job from a technology operations point of view. And then the cyber criminals, there was some research done that was uncovered by a group we're familiar with, who said that at one time 2 years ago, even more recently 12 months ago, the cyber criminals who were penetrating intrusion prevention shields were then planting malware that was extracting information out of the enterprise using simple FTP, and nobody was watching. So that was fascinating to know that. There's also other techniques these cyber criminals are using, and that's becoming a very interesting, that bottom one right there is very interesting. It's the cat and mouse game of the good guys and the bad guys, and it's quite interesting. Next slide. This is where we get to what you now have. The GB2010 on the left is a 3U network appliance that you guys now have 2 of them. This technology came to market in 2009-ish and are in beta, and 2010 and 11 commercially. And it is designed to do what I just described. Generally speaking, I'll go a little deeper into what it does on data in motion only. It performed deep packet inspection and could hang with 10 gig networks. The roadmap, and why I think it says 100. Does that say 100, Kyle, or 10? I'm sorry.
It's 10.
10, I'm sorry, 10. The roadmap at that time was to get to 100. So, but that product was able to process 10 gig network traffic. They're easy to deploy. You'll be the judge of that next week, Kyle, I think, when you guys install it. And Dina will be there to assist you. And from a functional point of view, it does 2 things at a very high level that I'll describe in a couple slides. It does application identification and content visibility and control. So that device has inside of it an Altera Stratix 2 FPGA technology. And that's what you've got. So the GB2020 came to market in 2012, last year, and it's being branded as Global DPI. It's a smaller footprint device. It's a 1U, as you see, lighter weight, but it's got a faster FPGA. It's got the Stratix 4 from Altera, which has more capacity, so we could do more things with it, and we had increased throughput. We decided to stay at mainly a 10 gig stable platform there, but the roadmap went to 40 pretty fast and then to 100. So generation 1 was the 2010. Generation 2 was the GB 2020. And now the next slide is what we're working on right now. And we are at commercial market entry with this. We pivoted, which some of you will find interesting. We pivoted for a number of different reasons, which I probably won't get into a lot of detail today. But we chose to take all of our learnings in pattern matching and protecting data. And we've engineered a product that is based, this is a commodity platform. It's a Dell server, private label for Global Velocity. It gives us a lower price point in entering the market. And it also allows us to play in the virtual world, to virtualize and run things, do things extremely fast. And additionally, it allows us to play in the cloud with data movement to the cloud. So Rapid DLP is what our engineering team is nose down working on. We've got version 2.4.2 and almost all the resources of our company right now are focused on this problem. Next slide, please. So I wanted to take a minute. Is just a question, Kyle, process check. Is the slide deck up? I see the image of Brian Thomas Rogers up.
Are you still seeing him?
Not anymore. Now I see the slide deck. Thank you.
Okay, thanks.
So I wanted to spend just a minute in the way we thought about solving this data loss problem using the FPGA, the 2010 and 2020, where we developed, for the FPGA, signatures for application signatures for over about 100 content-carrying applications. And this became a real challenge for our company because these application signatures changed all the time. So we had signatures that were granular. This gave you an example. If you did the eye chart, Facebook, we could tell the difference between a Facebook note, a Facebook post, a Facebook chat. We could get that granular in identifying what was going on in the flow. But it got very difficult. So the device, the 2 GB 2010s you have signatures that you're going to, when you start using this device, those signatures are now obsolete. So that's not a useful function of this device. And we wanted to be very candid with you and upfront with you out of the gate. But that was an interesting approach. It became a real challenge to stay with. We're a small company. We're less than 20 employees, and we have a lot of irons in the fire, and we have some choices to make. And that was one of them. But I did want you to just know that we were doing this, not only network processing in the FPGA, but we were doing this application identification in FPGA as well. Next slide. Now this is the piece that is operational in the device that you have. It's operational for the customers that have this, and that is to perform the content visibility and control. So the product comes with a series of regular expression matching capabilities where we can look for something in the network flow that looks like it might be a credit card or a social security number. So it has those two regular expressions. We also had some techniques to protect data that lived in a structured database like Oracle or Excel or SQL or or whatnot. And then unstructured data would be the data that lives on file shares, CIF shares, NFS, DFS. This would be up to 400 file types, Word docs, PDFs, so we can scan. So in the flow, we can crack open a zip file of PDFs and we can interrogate the content. And so that's what, this is the content visibility and control that is built into the products that you've now got. So there was the application piece and this content piece. And these features can be accessed through what's called the policy manager. When you begin hands-on with our device, you'll be able to play with and experiment with and work with the policy manager on this capability. And I believe there's some documentation I'll be sending you, soft copy, Kyle, for you guys to have as well. Next slide. So now let's talk about moving forward. And that is that, just to summarize, you've got a very interesting network appliance with Altera Stratix 2 FPGA chips to have fun and to get serious. The network connectivity is all the network connectivity is there. And bottom line, what this is designed to do is pattern matching. We've chosen to do pattern matching on the network flow. You guys may choose a different problem that we had talked about earlier. In talking with our engineers yesterday to prepare for this call, they did, and you're a little bit over my head being the business development guy, but you would need, I believe it's pronounced Quartus from Altera, in order to do the FPGA synthesis, which is not included with our donation, but hopefully you've got access to that through your faculty or other collaboration partners for the university. Dina will be your liaison for installation and connectivity and network and any device issues, and then I would be your liaison for regular collaboration. I look forward to it. However frequently you'd like to touch base with me to talk about what you're doing and for your feedback to us. And then I do have the ability, a limited ability, to bring some engineers or an engineer to the conversation as you guys aggregate some thoughts and thinking through Kyle.
Okay.
And Colin, okay? So my contact information is on the next slide. And so that kind of concludes my prepared remarks. I'm ready now, Kyle, for questions, if that's okay with you guys.
Yeah, and thank you for taking the time out of your sure busy schedule to meet with us today. And
of course,
we got some, I think of several questions. Hopefully you'll be able to answer.
I'll do my best. If I can't, I'll tell you.
First of all, Colin, do you have anything to add right now? If you can hear me, that's a no. Okay. Brian, do you want to say anything?
Yeah, and I know are we gonna show this Friday?
Yes.
We're showing this Friday? Okay. Just for clarity, could you give a brief explanation of what exactly is deep packet inspection? Just like a brief description of what it is, perhaps.
So I'll compare. I'll tell you what a prospect told us once when our engineers, the technical engineer who goes with me on sales calls, when he described what deep packet inspection is. We're basically examining the entire packet in the flow. And somebody paraphrased that deep packet inspection to be, oh, you do complete packet inspection. Some technologies only looked at header information and other things at the top of the packet conceptually. Right. We're looking at the entire packet, and that's deep packet inspection.
All right.
Thank you for the question.
Yeah.
All right. Let me pull up some more questions here from other people. So while we're on the topic of deep packet inspection, can you still hear me okay, by the way?
Yes, I can.
Okay. While we're on the topic of deep packet inspection, you know, since the we've had a growing interest in cybersecurity, and specifically within the last couple of months and year with the NSA and Edward Snowden and all of that. What can your company? What is your company's thoughts as far as the negative stigma now towards things like deep packet inspection and cybersecurity in general?
Yeah, that's really interesting, and I know in some quarters Eric Snowden is viewed as a hero, and that we do have a constitution, and we have rights, and there's some real question now as to you know what's really going on. And so we know we play in a very interesting marketplace that's all about protecting data. And what's interesting for us in our most recent conversations, even the last 3 years, was the number of people who represent the privacy side of an enterprise. Now, we think our positioning of ourselves is that we help protect privacy. I mean, we can't stop the NSA. We just can't. You know, they're going to do what they're going to do. Our goal as a company is to protect and defend, and that those things are to protect data and ultimately to protect privacy. And that's what we try to do.
Okay. I guess next up, especially concerning these GV100 boxes, what would you like personally for the U of I at Springfield and our club to do in order to help you reach your goals as far as anything related to what you just spoke of?
That's a really good question. Thank you for asking it. In our opinion, using those two devices, the two GV2010s, to stay on that data loss prevention problem would not be a good use of your time or ours. We hope that your club and the university take this and find a new problem, and to leverage that. So use the principle of crawl, walk, run. Take your time, soak in what this does. Start to walk. Solve a problem. I think Professor Ron Louie feels it's potentially in the antivirus world, maybe. There's some problems there that he's more familiar with, that he might guide you guys in that direction. Whatever it is, that's good. Whatever you choose to do, that's good. Ultimately, it's the university's goal and ours that through your efforts, the National Science Foundation, potentially the Department of Homeland Security, or some other grant, award, funding source could pay funding to substantiate investments in our newest stuff so that we get revenue and you get grant money, and you have then faculty getting paid and students getting paid to do more good work. So it's this crawl, walk. So then we're running. So for starters, crawl, walk, solve a problem, and then we're ready to run and go at grant funding. That would be huge.
If you could request that we complete one project with these machines, what would that be?
One project. I can't. So I'm not the right guy to ask what problem you should solve. But I will tell you, I will suggest to you that there's a whole avenue to look into if you have time and interest, is that we have some patents around applying what's called the Bloom filter to the FPGA technology on network flow. And it's safe to say, and it's not a secret, that we're still looking for the right problem to solve with those patents. So I'll toss that back to you guys.
Right. I think that's kind of a growing thing with cybersecurity. You can try to stay ahead of the game, but you never are. That's there's always a new exploit every day.
Yeah.
And I think it's a very interesting problem.
Yes. It's I believe you guys call it the cyber war range, right?
Right.
Warfare? It is. Are my weapons better than yours? Yep.
Colin or anyone else, you have any questions before I continue on? Josh? This is Josh Smith, who joined us a little late. He was watching, not actually participating, but
I met Josh. You were here the other day.
He has no microphone, so I will say yes, he was.
Thank you for joining us.
Okay. We've been going for, it's about 10 after 5 now, so I was going to go ahead and start kind of close here. If you could give one piece of advice to a computer science student thinking about entering the field, specifically cybersecurity, what would that advice be?
The relationship between information technology and the business has been a fascinating one through my career. And I date in this industry, IT, since 1980. And so what I recommend is that this business is all about people, and that business people should do their best to learn technology as much as they can. And I know I have my limits, but I try to hang. And technologists should reach across the hallway and learn about the business. So I would suggest to a senior, have fun and go deep and learn your technology to your heart's desire. But ultimately, you're going to be out there solving business problems with technology. So learn something, whether it's a functional area, like for me it was finance. I was a finance major, and here look at me selling computer systems, security systems. Or if you have a passion for farming or healthcare or nursing homes, is to learn a business. And you're going to find amazing problems to solve across the spectrum of business. So not only the big businesses of the world, but small businesses need a lot of help. And so learning finance or marketing or law or HR or whatever the function is, or to learn the flavor of a business, what it's like to run a farm, what it's like to run a doctor's office, that's a beautiful marriage.
Right.
When somebody has the talent that can put a foot in both camps and deliver value.
And I think that's kind of something I've noticed is, in the limited time I have worked in industry, it's every business has their own unique problem set, and it doesn't necessarily translate to others, and so I think that's some very good advice, and I thank you for that.
Of course.
can you kind of give us a little more background on yourself as far as, education for you and kind of how did you get into the whole information technology world?
Thank you. So I grew up in Cincinnati, Ohio, attended Princeton High School, and went to a 4-year program at Bowling Green State University in Northwest Ohio, just south of Toledo, just below Michigan, up there in the northwest corner. And it was there that I majored in finance and took IT courses through my sophomore year and just chose to focus on finance. And then so my dad was a salesman. And my dad was one of my heroes in life, and I wanted to be like him, but I didn't want to sell what he sold. So I sold finance stuff. I sold. I represented a bank. I sold life insurance for a while. I call that the graduate school of selling. Selling life insurance over a kitchen table is not easy. But a friend of mine who worked for a payroll service bureau, believe it or not, in 1980 said, Mike, will you come sell for us? And so that really, when you think about payroll services, are really cloud computing today. We had a big data center. In 1980, we had a data center with key punchers, and we ran payroll checks every day. We printed them out, and we delivered them, and now that whole model has changed. But that's how I got my foot in the door. Then I went to work in 1987 for a brand name some of you might remember. It's in the Computing Hall of Fame now, DEC. I was a Boston DEC guy, Digital Equipment Corporation, who was famous with PDP-11. Ken Olson, the founder and CEO, was famous for having invented distributed computing. DEC broke the glass house and brought computing into the functional areas, mainly R&D and manufacturing. And I was a DEC guy. It's called on Procter & Gamble, was my customer for 10 years, one customer. And I learned a lot about Procter & Gamble's business and sold them a lot of systems that solved their problems. And then I got into IT consulting. Do some of you remember Y2K? So I was part of the Y2K solution group and helping companies figure that out, and IT staffing and consulting and software development. And then 10 years ago, I got into data, the data part of computing, this whole focus around data. First, data, something called data synchronization, and then operational database administration. And then 6 years ago, I got into data protection and data privacy. On the personal note, I've been married to Denise for 36 years. We're going to Ireland next Friday, so I'm off the grid for 2 weeks. I'm going to try it. And our daughter, Kristen, and Tim have been married 7 years, and they have a little baby who's our grandson. And my hobbies include yoga, golf, and I volunteer in 2 groups in Greater Cincinnati. So that's a little bit about me.
Thank you. Thank you for sharing that. Another question I had, as far as security goes on the computing level, not necessarily cybersecurity, but I think consumer security has become a major problem within the last couple of years as well, with the rise of a lot of these exploits lately. Java, a big example.
Yeah.
Do you have any ideas as far as how to better educate, I guess, the consumers about how to stay safe online?
I hope you don't think this is a goofy response, but I truly thought I had a light bulb go off at a conference when my wife's dad, who is 80, he hit one of those links he shouldn't have hit, and they had a mess. And so truly, it gets down to teaching people in a simple way. And there's a lot of ideas out there, and the example I'm going to use for you is something I grew up as a little boy. There was Smokey the Bear said, "Put out that forest fire." So there's this national advertising campaign about forest fire prevention to save our nation's forests. Well, why can't, so maybe does University of Illinois have a marketing communications group? If they could come up with a clever campaign about don't click on that link, you know, just don't do it, and make it into a national where our congressmen adopt it, our country adopt it. It's kind of a Smokey the Bear thing, and I think it worked. And I think our industry could use something that simple for, in my family's case, my wife's father and many others like him who click stuff that they shouldn't click.
And I think that's...
Do you guys remember Smokey the Bear, or is that before you?
I do remember that.
Good.
Josh nods.
Good.
No, I think that's a very good idea. And I know next month, October being Cybersecurity Awareness Month as well, we're trying to do a few things around our campus. We haven't necessarily reached out to Urbana-Champaign at U of I, but we're definitely planning on doing a few things at the campus level, and hopefully teaming up with information technology services on campus as well to try to kind of spread the word on how to stay safe online.
I'll ask you to consider expanding your audience to include the community.
Right.
The grandmas and the grandpas and the moms and the dads that may not know any better, to help them get smarter too. Awesome.
Brian, Colin, anyone else have any questions for us?
No, but I do have to say thanks for the hardware. This is definitely an awesome project that we're pursuing. So, and I just can't wait to sit at the computer and break stuff.
Well, good. And our CEO, Greg Sullivan, if you go to our website, Greg and Ron are friends, Ron Louie. So just know that, you know, we're watching you guys and we wish you the best of luck. We have limited ability to help you, but you're in good hands with guys like Josh Smith and Ron Louie and others. So I'm here to help if I can. So just reach out to me if. So I'll be out of touch until the week of August 20th. So if you reach out to me the week of August 20th for a follow-up, I'll be ready for you.
August 20th?
Well, did I say August? I meant October.
Okay.
My mind is already in Ireland. There you go. October. Thank you.
I knew you were going offline, but man, for a year, I couldn't do that. Okay, I think that's it. And I wanted to thank you again, Mike, for everything you've done for us. And you know, I hope to stay in contact quite a bit, and hopefully see what some great projects we can do with your guys' donation.
Good luck and have fun.
Thank you.
Thank you all.
Thank you.
Bye-bye.